Hey Longhorns, Miss Flores here with a quick tutorial on problem solving in science. You may not realize it, but our lives are just a cycle of problems, one after another. We're bombarded with them on a daily basis, and you're working at solving them every moment of the day. Have you ever asked yourself what you want to wear in the morning while you're getting ready for school? This is a problem. How do you go about solving it? You learned about the scientific method way back in elementary school, and believe it or not, you're using it almost every day to solve problems. The first thing you do is ask a question, like what you want to wear to school today. Then you do a little background research to figure out what you want to wear. So what's the temperature outside? Is it cold or is it hot? Are you going anywhere after school? Do you need a change before or after? You're going to use the answer to your research to develop a hypothesis, what you're going to wear for school that day. Then you're going to test out your experiment by actually wearing whatever you've decided. Let's say that that's shorts and a t-shirt. You're going to analyze your results after wearing said outfit for the entire day. Well, let's say your shorts were too short. You got caught as soon as you walked into the building and you had to wear those long maroon GR athletic shorts. You were cold as soon as you walked outside. So you're analyzing your results and you're drawing conclusions. It wasn't a great idea. Your outfit was not the best choice. You're going to report your results. So as soon as you had to change into those GR athletic shorts, you probably sent text messages to all of your friends, maybe a Snapchat about how terrible and upset you are about the ludicrous rules and how you won't be wearing the same thing again. This is just an everyday example of how we can use the scientific method to solve problems. Now let's apply it to science. It's often really challenging to study for science tests because most questions are applications of the content you learned as opposed to just memorization of the content that you learned. I suggest you use a scientific method approach to solve problems. Step 1, identify and understand the problem being asked. Step 2, devise a plan to solve the problem. Step 3, carry out your plan. And step 4, analyze your results. Here's an example of using the problem-solving method in biology. Step 1 is to identify or understand the problem. I have a data table about pond water organisms with characteristics. Based on the observations, which organisms most likely belong to the taxonomic group for bacteria? I've identified my problem as what are bacteria? That's basically the question they're asking me. Step number 2 is to devise a plan. Well, my plan includes to look for defining characteristics of bacteria. I know they're all single-celled. I know they have no nucleus because they're prokaryotes, and no membrane-bound organelles, and most of them have cell walls. Step number 3 is to carry out that plan. I'm going to look at the data table and find which organisms fit the characteristics of bacteria. And step number 4 is to analyze your results. Do I see an answer choice that includes both organisms 2 and 3 that have the defining characteristics of bacteria? And they do. Answer choice D. Now let's try problem solving in chemistry. The diagram below represents a nuclear reaction. I see a neutron hitting a target nucleus that's breaking apart into 2 smaller nuclear fragments and also giving off 3 small neutrons here. 1, 2, 3. Which of the following best describes this reaction? So step number 1 is to identify my problem. It looks like the problem is, what type of reaction is this? Step number 2 is to devise a plan. Well, by looking at the picture here, it looks like either this is nuclear fusion or nuclear fission. So I'm going to define what I currently know about fission and fusion. Fission, one big nucleus splits apart into 2 smaller nuclei, whereas fusion, 2 small nuclei fuse together into 1 larger nuclei. So I'm going to look at my answer choices and I'm going to carry out my plan. I see that I've got 1 big that's breaking apart into 2 smaller pieces, so this must be fission. I'm going to look at both of my answer choices that include fission, which are answer choices G and J. And then I'm going to identify which of those is best. Nuclear fission is occurring because large amounts of energy are being absorbed, or nuclear fission is occurring because a nucleus is being split into smaller nuclei. And J actually fits the exact definition of fission, so it is my correct answer. I'm going to analyze my results. Am I looking at the picture? Is it 1 big nucleus splitting into smaller nuclei? I do in fact see that. This is my right answer. All right, we're going to try one more problem-solving technique in physics. by using the same strategy. Step 1 is to identify the problem. An airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. I've identified the problem as distance traveled. Step number 2 is to identify or devise a plan. My plan is going to be to solve for distance by using a formula that includes both acceleration and time. By looking at a formula chart, I can tell you that distance is equal to initial velocity times time plus 1/2 times acceleration and time squared. Step number 3 is to carry out my plan. I'm going to list my variables over here off to the left-hand side to help me stay organized. And I'm going to fill in my information. I'm solving for distance, that's my problem. The initial velocity, if it was an airplane at rest, is 0 meters per second. The time traveled was 32.8 seconds. And the acceleration is 3.20 meters per second squared. In order to finish carrying out my plan, I have to take my variables or my number for the variables and plug them in. Initial velocity was 0, and anything times 0 over here, so this VIT, that's going to be 0. I'm going to put a 0 for the whole thing. That's just going to make my life easier. Plus 1/2 times acceleration. My acceleration, according to my variables over on the left-hand side, is 3.20 meters per second squared. And my time is 32.8 seconds. 32.8 seconds, and I have to square that value. So the last thing I have to do is put these values in my calculator to solve for my final answer. And once you plug them all into your calculator, you should get to 3 significant figures, 1,720 meters traveled. I like to put a box around my final answer, just like I put a box around distance since that was a problem I was solving for. So in conclusion, use the problem-solving approach to solve problems on your science tests. Put a box around the problem. That helps you identify your end game. Underline information provided that will help you devise a plan. Carry out your plan in an organized manner. The more organized it is, the faster you can get to the final answer. And analyze your answer to ensure it's logical. Once you have an answer, you put a box around it, go back to the information provided. Is it logical? Is there an answer choice that matches what you have? Feel free to stop by room 2005 if you'd like additional tips on problem solving in science. Thanks, Longhorns.